Okay, hello everyone. This is just another short video uh, demonstrating how to run different statistical analyses using Python and the software libraries that are available within Python. So in this video, I'm going to be focusing on data wrangling. So I'm going to be using the pandas software library to kind of handle data and data frames within Python and show you how you can manipulate data. Often when we get a data set, we collect some data from research, or we inherit some sort of data set that we're going to analyze. It's often not in the format that we want it in, so we have to kind of do some wrangling, do some manipulation, do what's often referred to munging or cleaning, tidying of the data to get it in the format that we need it in to analyze. So in this and the next few videos, I'm going to kind of show some of the ways you can manipulate a data set once you have it imported into Python. And again, I'm working using a Jupyter notebook. So let's get started. I'm going to try to keep these videos as short as possible. So firstly, as I said, I'm using pandas, which is I think it's an abbreviation that stands for panel data. So it's very useful. It's got a lot of functionality when working with data sets in Python, and it kind of helps to create data frames. It can be used to create and manipulate data frames that we would describe as kind of panel data frames of the sort that you're probably familiar with. You're using in something like an Excel spreadsheet. Okay, the difference obviously when you're analyzing and manipulating data using Python or some other programming language like R is you don't directly have your data in front of you all the time. It's been manipulated in the background. So to start off, the first thing we're going to need to do, as I've done in other videos, is actually import pandas. So I already have pandas installed in the environment that I'm working in Python. So I'm gonna import it so I can use it, and I'm going to import pandas as PD. As I kind of mentioned in previous videos, it's often the case that when we're importing software libraries to use in Python, we give them these abbreviated nicknames, and it makes it easier than just having to type out the full name of the library each time you want to use it. So now I've imported pandas as PD, I can refer to it as PD when I'm calling methods or functions from pandas. Okay, so I'm not going to actually import any data this time. I'm going to actually show you how you can create a data frame from scratch using pandas. And to do so, if you look at this second cell here that's highlighted, what I'm going to do is use what's known as the pandas dot data frame method. And notice, it's worth noting here that data frame, the capital D of data and F of frame are, the first letters of each of those are in capitals. Okay, so it's important, if you didn't have them in capitals and you tried to run this, it wouldn't recognize the method. Okay, so what I'm going to do is I'm going to basically create a data frame object. I'm going to save it as the object called df. That's quite common when people are doing data analysis in Python. They'll refer to the data frame as df data frame. And I'm going to use the pd.dataframe method. I'm going to create some columns. Initially, so that's what this first line is saying, is create a data frame object that has columns with the names age, name and ID. And then the second line, what I'm doing is that I'm saying in relation to that data frame called df, I'm going to create a new for the variable age, which is saved as a column name. I'm going to enter a list of values. Okay, so 6 values is all I'm putting in. And when you see square brackets like this and anything contained within them, that's what's referred to as a list in Python. So here, these are just integer values to represent ages of whoever the people are who are involved in this particular, whose data this refers to. So I've got initial data frame with 3 columns, aim, age and ID. Doesn't have the data in it, but now with this second line, I'm adding a list of 6 values, 6 integer values to the age column. And then for the name column underneath that, I'm adding a list of 6 strings, which are the names of the participants, let's say. So there's Rob, Cheesy, Indy, Sam, Chris, and Ben. Okay, and they're saved as strings. You can tell that they're strings in Python because they are enclosed within quotes. So you can use double quotes, like I'm here for name, or you can use single quotes, like here for the dates of birth. Doesn't matter, just as long as you're consistent with which ones you use. So the next thing, I've just created some sort of ID. Let's imagine we'll create there's some sort of index number, unique reference number relating to each participant in this data set. So here I've just passed another list, which is a list, again, a list of integers. These are 2, 4, 7, 1, 3, 5. So they're not 1 to 6. 6 is missing from that list. Let's kind of imagine they represent some sort of unique reference number, and the data we're creating has some purpose to it. The last thing there, I'm taking, so in the initial data frame we created 3 columns, 3 variables, age, name and ID. We've then added values to each of those columns. And what I'm doing after that is I'm kind of, in this line here, we didn't create a date of birth variable or column, but I'm now adding that on with this last line. And in one move, I'm basically creating that new variable, that new column, and adding a list of dates of birth. Okay, so if we run this cell, if we run this cell without putting the df at the bottom, then it'll create the data frame, but it won't print the output. But where I've put df at the bottom here, that's gonna, when I run this, it's actually going to call the data frame, and we will see that there it is in the output. And pandas creates these nice HTML data frames with bold lettering for the column names and bold lettering for indices. So it gives each row, each participant, an index. And remember, Python is 0 index, so the first value is going to be 0. And now you can see we've got a list of ages, names, ID numbers, and dates of birth for each of our participants. And they were inputted differently, you can see. So some of these had the full kind of year inputted, and some of them just had 2 values for the year inputted. And because they were saved as strings, these are just string objects. Python will do that. But one of the issues we have here though now is we've got this list of dates of birth formatted in a way that's inconsistent. They're not all formatted in the same way. So this might be something we'll need to manipulate at some point. But okay, so this was a short data frame, so we could just basically create this data frame and call it using df, the object name, and it shows the whole thing. And if we had a much bigger data frame and we called it using the object name for the data frame, it would print the whole thing to the screen. If you've got lots and lots of rows and rows, hundreds of participants, maybe you don't want that. So we could just look at the check to see if it's imported properly or being generated properly using the head method. And we've seen this before. I'm kind of reiterating stuff we've seen before, repeating stuff just to sort of drum it in. And if we specify how many rows, it'll just return, here I've put 2, so I'll just return the first 2 rows of data. So we could see there, or we could use the dot tail method to look at the last 2 rows. By the default is 5, it returned the first kind of 5 rows of data. In this case, that will be all the data set apart from the last line if we did that. But if you have a really large data set, you generally don't want to print the whole thing to the screen. You just want to check that it looks correct. We could do a similar sort of thing using print statements, so the print function. So what I've done here is I'm printing the head and tail. Firstly, I'm printing these are the top rows, printing these are the bottom rows, and then I'm using the .head method encompassed within the print function to print out the head and the tail. And if I run that, you can see it gives us those top 2 rows from the header and bottom 2 rows from the foot, the tail of the data set. But where I've used the print function, notice now that they're not nice kind of looking HTML tables. It's just the kind of data. It's just giving us what we need, but it's not as aesthetically pleasing. Okay, so a couple of other things, and then we'll end this this video. So we can select contiguous portions of data. So maybe we want to select certain sections of data that we're interested in, and we want to save them as a separate object. So we've got our original data frame created there, df. Maybe we just want to interrogate and manipulate part of that, do analysis on part of that, so we can extract bits of that, and it's usually useful to save it as a separate object and then manipulate that separate object. Okay, and here I'm basically using what's known as the iloc function, which stands for integer location, and I'm going to use that to just select certain rows, certain columns from the data. And remember, where in a lot of programming languages, when you specify from data when you're trying to extract slices of data, these things are recorded as row column pairs. So where after the iloc function here in brackets, we've got a series of values. The first two values before the parenthesis, before the comma, 1:4, says that's basically specifying we want rows 1 to 4, and the second one after the comma, 1:3, relates to columns, so it's asking for columns 1 through 3. But it's important to remember that in Python, whenever you specify values like this to select a portion of data, to take a slice of data, the first value is inclusive, so it will give us row 1, but the second value is exclusive. It won't include the second value. So 1:4 will return rows 1, 2, and 3, but not 4. 1:3 will return columns 1 and 2, but not 3. Okay, so it's important to remember that, because if you often have to, if you wanted columns 1, 2, and 3, we'd have to specify here 1:4. Okay. So all I'm doing with this call here is I've printed a line there just so you can see above. I'm showing 2 columns and 3 rows, starting from the second row. Remember, because Python's 0 index, so we ask for row 1, 2, and 3 here. It's going to miss off the first one. If I run this, if I call this new data frame object, dfnew, if I run that, what we get is this. And if we go back and look at the original data frame, what we're seeing is we're getting columns 1 and 2. So 0, 1, 2, so we're getting name and ID, and we're getting rows 1, 2, and 3, and remember that's 0 indexed, so it's given us basically these two columns, and just these 2 rows, these 3 rows, sorry. We asked for rows 1 to 4, so rows 1, 2, and 3 is returning. Okay, right, so another way we can do this is we can just select specific columns by passing a list, create a new object and passing a list telling pandas which of our columns, which of our variables to include in this new object. So here I'm saying creating dfnew2, and then from the original data frame I'm just passing a list containing ID and age. So that will give us just those 2 variables, just those 2 columns for all values. Okay, and notice here we've got this double brackets notation. So this is a list of 2 values, and it's contained within the double brackets for the data frame as well. So if we run that, you can see it's just going to give us ID and age, but it's going to give us all the rows because we've not specified a slice of rows to take. Okay, so that's as far as I'm going to go on this video. I'll record another one following on from this, where we'll cover some more of these types of things. Next up, we'll look at renaming columns. Okay.